Hey, we've got two more structures to do. Previous video we worked on octahedral, which is as many things as you can put around a central atom. It doesn't get any bigger than this, okay? So obviously the next thing we want to do is we want to take one off, okay? So we're going to make a structure that kind of looks like this. Now, the example molecule that they've given us is BRF5. So let's first name it, and that would be bromine pentafluoride. And we use the prefix because this is a covalent compound, and remember, covalent compounds are the only ones that ever use prefixes, okay? And so we have 1 bromine, 5 fluorines, so, and then fluorine is the more electronegative, so it changes its name to IDE. And we're ready to go. We're in business. Now, the first thing I'm going to want to do is make a Lewis structure here. And so bromine, I have one of those that has 7 valence. Fluorine, I have 5 of those, and that also has 7 valence. So 7 and 35 is 42. So I have 42 total valence electrons that have to go on this model. Now, again, the first one, the central atom has to be bromine because it can violate the octet rule, whereas fluorine just can't. Okay? And so I have 5 fluorines, and I'm going to attach 1, 2, 3, 4, 5. Fluorine, 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 and that's going to be my skeleton. Okay? So remember, once you've decided what your central atom is, everything needs to be attached into that central atom. If you have 2 central atoms, like it's a carbon thing, that's obvious. You put those on first, and I'll go through that in another video. Don't want to go too far afield here. But this one we have 1 central atom, and we've attached everything that needs to be attached. And in doing so, we use 2, 4, 6, 8, 10 electrons. So I'm going to have 32 electrons left over. And I think the next thing is that fluorine is going to need 6 apiece. So I'm going to do that. Alright, and so when I do that, 2, 4, 6 apiece, and then those make all the fluorines happy. So 6 times 5 is 30. And that means I have 2 left over. And the only place to put that is right there at the bottom. Okay? And so, let me bring my model back. And you can see that when you have 6 things, 1, 2, 3, 4, 5, unshared pair is 6, around a central atom, what's going to happen here is you're just going to have your unshared pair here in the spot where previously one of the things was bonded. But you see how this looks. Now, you might remember that we had trigonal bipyramidal, and we had trigonal pyramidal, and all, those. Now, this one is called square pyramidal, okay? And the reason why it's square pyramidal is before, octahedral made 2 pyramids with 4 side bases. You take one off, and you only have 1 pyramid. So we call it square pyramidal. It's got 90-degree angles, and I draw it BR, and then I'm going to have a fluorine going up. I'm going to have 2 fluorines going back. And I'm going to have 2 fluorines going forward. And the reason why this is taking a minute is I'm putting all those unshared pairs on there, which you should do as well. And then I'm going to put the unshared pair on the bromine. So that's how it looks. And so the two forward, the one straight up, and the two back. You can kind of see how that resembles that. Okay. And let's go ahead and look at formal charge for the bromine and the fluorine. Fluorine, oh my gosh, we've done the fluorine formal charge so many times. 7 minus 6 unshared plus 1/2 of 2 is 1. 7 minus 7 is 0. Fluorine's good. Now for the bromine, bromine has 7, and it has 2 unshared plus 2, 4, 6, 8, 10 in a bond. You know where this is going. 1/2 of 10 is 5. 2 plus 5 is 7. Bromine is also 0. There's your fluorine calculation, your bromine calculation. We're all good. That structure is great, guys. See you for the next one.